Dear students, good morning everybody. Today we are going to learn arithmetic progression. Grade 10. You must have observed that in nature many things follow a certain pattern, such as the petals of a sunflower, the holes of honeycomb, the grains of a maize-cob, the spirals on a pineapple, and on a pine cone, etc. We will now look for some patterns which occur in our day-to-day life. Day-to-day life. Some such examples are: Rina applied for a job and got selected. She has been offered a job with a starting monthly salary of rupees 8,000 with an annual increment of 500 rupees in her salary. Her salary in rupees for the first, second, third, dash 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 so on. Years will be respectively 8,000, 8,500, 9,000. Next comes 9,500, 10,000, and so on. Second example is the length of the rungs of a ladder decreases uniformly by 2 centimeters from the bottom to top. The bottom rung is 45 centimeters in length. The length in centimeters of first, second, dash dash dash, eighth rung from the bottom to the top, or respectively 45, 43, 41, 39, 37, 35, 33, 31, 29, and so on. Next example is, in a savings scheme, the amount becomes 54 times of itself after every 3 years. The maturity amount in rupees of an investment of 8,000 after 3, 6, 9, and 12 years will be respectively 10,000, 12,500, 15,625, 19,531.25, 25. In the above examples, we observe some patterns. In some, we find that succeeding terms are obtained by adding a fixed number. In the other, by multiplying with a fixed number. In another, we find that they are squares of consecutive numbers, and so on. Next, the number of unit squares in squares with side 1, 2, 3 units. Now look at the figure, or respectively 1 square, respectively 1 square, 2 square, 3 square. Shakila puts rupees 100 into her daughter's money box when she was 1 year old and increased the amount by rupees 50 every year. Means year we are adding 50 rupees for every year. The amounts of money in the box on the first, second, third, fourth dash dash birthday were 100, 150, 200, 250 respectively. Here, in fifth example, a pair of rabbits are too young to produce in their first month. In the second and every subsequent month, they produce a new pair. They produce a new pair. Each new pair of rabbits produce a new pair in their second month, and in every subsequent month as shown in the figure. Assuming no rabbits dies, the number of pairs of rabbits at the start of the first, second, third, sixth month respectively are 1 pair. Here second 2 pairs. Next is 3 pairs. Next is 5 pairs. 1, 2, 3, 4, 5 pairs. Next is 8 pairs. 1, 1, 2, 3, 5. Last one is 6th month. That is 8 pairs of rabbits. Okay. These are procedure in arithmetic progression. Okay. Now come to the point. What are arithmetic progressions? In this chapter, we shall discuss one of these patterns in which succeeding terms are obtained by adding a fixed number to the preceding terms. We shall also see how to find their nth term and sum of n consecutive terms, and use this knowledge in solving some daily life problems. Consider the following list of numbers. Some problems. Consider the following list of numbers. First example is 1, 2, 3, 4. Second, 100. Here adding 1 plus 1 we will get 2. 2 plus 1 we will get 3. 3 plus 1 we will get 4 dash dash dash. Next, in second example, 100 minus 30 we will get 70. 70 minus 30 we will get 40. Again 40 minus 10, that is 30, that is 10. In third example, minus 3, minus 2, minus 1, 0, dash dash dash. Here in fourth example, 3, 3, 3, 3 by adding 0 or subtracting 0. Next list of numbers is minus 1.0, minus 1.5, minus 2.0, minus 2.5. Each of the numbers in the list is called a term. Each number is called a term. Give a term, you can write the next term in each of the lists above. If so, how will you write it? Perhaps by following a pattern or rule. Let us observe and write the rule. In first example, each term is one more than the term preceding it. In next one, that is, each term is 30 less than the term preceding it. In third example, each term is obtained by adding 1 to the term preceding it. In fourth term, all the terms in the list are 3. That is, each term is by adding or by subtracting 0 to the term preceding it. In fifth example, each term is obtaining by adding minus 0.5 to, or that is subtracting 0.5 from the term preceding it. In all the lists above, we see that successive terms are obtained by adding a fixed number to the preceding term. Such list of numbers is said to form a arithmetic progression. Form a arithmetic progression. Simply we call it as AP. So, an arithmetic progression is list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This fixed number is called common difference. Is called common difference and it is denoted by D. It is denoted by D of the AP. This fixed number is called the common difference of the AP and it is denoted by D. Remember that it can be positive, negative or it may be 0. Let us denote the first term of an AP by A1 or A. Second term by A2. Nth term by An and the common difference by D. Then the AP becomes A1, A2, A3, so on dash 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 An. So, A2 minus A1 equals to A3 minus A2 equals to dash dash up to An minus 1 equals to D. Equals to D. Therefore, D equals to An minus 1. So, some more examples of AP are the heights in centimeter of some students of a school standing in a queue in the morning assembly are 147, 148, 149 dash 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 up to 157. Next, the minimum temperatures in degrees Celsius recorded for a week in the month of January in a city arranged in ascending order are minus 3.1, minus 3.0, minus 2.9, minus 2.8, minus 2.7, minus 2.6, minus 2.5. The balance money in rupees after paying 5% of total loan of rupees 1000 every month is 950, 900, 850, 800 dash 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 up to 50. Here you look at these numbers. It is ending with 157, minus 2.5 and 50. Next, the cash prizes in rupees given by a school to the toppers of classes 1 to 12th are respectively 200, 250, 300, 350, ends within 750. In fifth example, the total savings in rupees after every month for 10 months when rupees 50 are saved each month are 50, 100, 150, 200, 250, 300, 350, 400, 450. Next, 500. It is left as an exercise for you to explain why each of the lists above is an AP, means arithmetic progression. You can see that A, that is first term, A plus D, that is second term A2, A plus 2D, that is third term A3, comma A plus 4D, it is fourth term A4, dash dash dash. Represent an arithmetic progression where A is the first term and D is the common difference. This is called the general form of an AP. This is called the general form of an AP. That is A plus D, A plus 2D, comma A plus 3D, comma A plus 4D, comma A plus 5D. These are called general form of an AP. Here, note that in examples A to E above, there are only a finite number of terms. There are finite number of terms. This is ending with one number. That's why finite number of only a finite number of terms. Such an AP is called the finite AP, means they are countable. Also note that each of these arithmetic progressions has a last term. Ending with a number. The AP is examples 1 to 5 in this section are not finite APs, and so they are called infinite arithmetic progression. Such as APs, arithmetic progressions do not have a last term. Examples. Now, to know about an AP, what is the minimum information that you need? It is enough to know the first term, or is it enough to know only the common difference, A or D? You will find that you will need to know both the first term A and the common difference D. For instance, if the first term A is 6 and the common difference is D is 3. D is 3. Then the AP is, first term is A, that is 6. A equal to 6 first term. Second term is A2, that is equal to A plus D, that is 6 plus 3. 6 plus 3, that is equal to 9. Second term is 9. Next, third term, that is third term, we denoted it by A3, that is equal to, in general form, we will write it as A plus two D, that is equal to A is 6 plus 2 into, they have given T is 3, we will get 6 plus 2 3s are 6, that is 12. That is 12. Third term is the 12. Likely, A4, that is equal to A plus 3D. A plus 3D. 6, 9, 12, 15. The AP is 6, 9, 12, 15 dash dash dash. And if A is 6 and D is minus 3, then the AP is 6, 3, 0, minus 3 dash dash dash. Similarly, when A equals to minus 7, D equals to minus 2, the AP is minus 7, minus 9, minus 11, minus 13. Again we can write minus 13, again minus 2. We will get minus 15. Okay, so on. If A equal to 1.0 and D equal to 0.1, then AP is 1.1, 1.2, 1.3, and next one is by adding 0.1 to it, we will get 1.4. Next term is 1.5, so on. Likely A equal to 0, D equal to 1, 1 by 2, that is 2, 1 j 2 plus 1, 3 by 2, D equal to 3 by 2. The AP is 0, comma, like this. And if A equal to 2, D equal to 0. If D equal to 0, all terms are fixed terms. That is 2, 2, 2, 2, 2, we will get it. So, if you know what A and D are, you can list the AP. What about the other way round? That is, if you are given a list of numbers, can you say that it is an AP and then find the first term A and the common difference D. Since A is the first term, it can easily be written. We know that in an AP, every succeeding term is obtained by adding D to the preceding term. So, D found by subtracting any term from its succeeding term, that is, the term which immediately follows it, should be same for an AP. For example, for the list of numbers 6, 9, 12, 15, that is D. D is A2 minus A1 equals to 9 minus 3, that is 3. Again D, we can find D, A3 minus A2, that is equal to 12 minus 9, that is 3. A4 minus A3 equals to 15 minus 13, that is equal to 3. Here, look at these numbers 3, 3, 3 means D equals to 3. This one is fixed. Here, the difference of any two consecutive terms in each case is 3. So, the given list in AP, whose first term A is 6 and common difference is D, is 3. Therefore, for this list of number, this is the AP. Given list is in AP. In next one, for the list of numbers 6, 3, 0, minus 3, so on, we have A2 minus A1, that is equal to 3 minus 6, that is minus 3. A3 minus A2, that is 0 minus 3, this is also minus 3. Next, A4 minus A3, that is also equals to minus 3. Similarly, this is also an AP because here also minus 3 is fixed. Similarly, this is also an AP whose first term is 6 and the common difference is 3. In general, for an AP A1, A2, dash, 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 AN, we have D equals to AK plus 1 minus AK, where AK plus 1 and AK are the k plus 1 and kth term of the arithmetic progression respectively. To obtain D in a given AP, we need to find all of A2 minus A1, A3 minus A2, A4 minus A3, dash dash dash. It is enough to find only one of them. Consider the list of numbers 1, 1, 2, 3, 5, dash dash dash. By looking at it, you can tell that the difference between any two consecutive terms is not the same here. So, this is not an AP. This is not an AP. Note that to find D in the AP 6, 3, 0, minus 3, we have subtracted 6 from 3 and not 3 from 6. Okay, that is, we should subtract the kth term from the k plus 1th term, even if the k plus 1th term is smaller. Let us make the concept more clear through some examples. Children? Okay, children? For the AP, 3 by 2, 1 by 2, 1 minus 1 by 2, minus 3 by 2, dash dash dash. Write the first term A and the common difference D. Here the solution. Clearly, the first term is 3 by 2. Therefore, A equals to 3 by 2. Common difference D equals to, that is, D equals to A2 minus A1. Here, A2, the value of A2 is 1 by 2 minus value of A1 is 3 by 2. 1 by 2 minus 3 by 2, we will get 1 minus 3 divided by 2, we will get minus 2 by 2. 2 1 ja, 2 1 ja. That is minus 1. Therefore, A equal to 3 by 2 and D equals to minus 1. Remember that we can find D using any two consecutive terms once we know that the numbers are in AP. Which of the following list of numbers form an AP? Form an arithmetic progression. If they form an arithmetic progression, write the next two terms. Next two terms. In first example, 4, 10, 16, 22. We have the solution for this. A2 minus A1. A2 is 10. Okay. A2 is 10. And first term A4. That is equal to 4. That is 10 minus 4 is 6. Next, A3 minus A2. A3 is 16. A3 is 16 and A2 is 10. Therefore, 16 minus 10 will get 6 here. Next, A4 is 22 and A3 is 16. Therefore, A4 minus A3, that is equal to 22 minus 16, that is equal to 6 again. That is A k plus 1 minus AK is the same every time. That is, we will get the fixed number. D is always 6 here. D is always 6 here. So, the given list of numbers form an AP with the common difference 6. Therefore, this is, and we have to find if they form an AP, write the next two terms. Write the next two terms. The next two terms are 22 by adding D to it, that is 6. 22 plus 6 is 28. Again next term 28 plus 6, we will get 34. In second example, that is 1 minus 1 minus 3 minus 5. For this, the solution is a2 minus a1, that is minus 1 minus 1. By adding 1 1 we get 2 and keep the sign minus here. a3 minus a2 minus 3 minus of minus 1 minus 1 minus 1 will get plus. Minus 3 plus 1, that is equal to minus 2. a4 minus a3, that is equals to minus 5 minus of minus 3. Minus into minus, again plus here, we will get minus 2. Now look at here, minus 2, minus 2, minus 2. Values are same, D are same always. AK plus 1 minus AK is the same every time here also. So, the given list of numbers form an AP, arithmetic progression, with the common difference minus 2. In third example, that is minus 2, 2, minus 2, 2, minus 2. Look here, the next two terms are for a last problem. For this problem, next two terms are minus 5 plus minus 2, that is minus 9. Again next term is minus 2, adding minus 2 we will get minus 9. In third example, look here, a2 minus a1, that is 2 minus minus 2, we will get 2 plus 2, that is 4. That is 4. a3 minus a2, that is equal to minus 4. One is 4, another one is minus 4. Differs here. As a2 minus a1 and a3 minus a2, the given list of numbers does not form an AP because D varies here. That's why these didn't form an AP. In fourth example, a2 minus a1, that is equal to 0. a3 minus a2, that is also 0. But a4 minus a3, that is equal to 1. a2 minus a1 equals to a3 minus a2, that is not equal to a4 minus a3. Here D values varies here, not a fixed number. So, the given list of numbers does not form an AP. In first and second example, D is same, that's why they form a AP. But in third example and fourth example, the list of numbers does not form an AP. In which of the following next is the home, dear students, next is the this is the time for homework. Okay, dear students, this is the time for giving homework. All of you write the homework. In which of the following situations does the list of numbers involved make an arithmetic progression and why? First one is the taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometers. And in second one, the amount of air present in a cylinder when a vacuum pump removes 14 of the air remaining in the cylinder at a time. Third one, the cost of digging a well after every meter of digging when it costs rupees 150 for the first meter and rises by rupees 50 for each subsequent meter. In fourth one, the amount of money in the account every year when rupees 10,000 is deposited at compound interest at 8% per annum. Okay. And Write first four terms of the AP. Here they are given A and D values. A and D values. We have to find first four terms of the AP. That is A. First four terms means A. Second one is A plus D. Third term, that is A plus 2D. You have to find. Next fourth term is A plus 3D. There are 5 questions in this. A equals to 10, D equals to 10. Second one, A equal to minus 2, D equal to 0. Third term, A equal to 4, D equal to minus 3. Fourth sum, A equal to minus 1, D equal to 1 by 2. In fifth sum, A equals to minus 1.25 and D equals to minus 0.25. You have to find these 4 terms. First 4 terms. In third question, for the following arithmetic progressions, write the first term, that is A. Write the first term and the common difference D. They have given a arithmetic progression. You have to find A and D. Which of the following are APs? Already we are seeing the examples like that only you have to do. If they form an AP, find the common difference and D. I write 3 more terms. In examples, only 2 terms we solved, but in this question, they asked to write 3 more terms. Okay. If you want, you take the screenshots of these slides. Okay. Okay, students. Thanks for watching. We will continue in the next video.